Since its debut in 2017, the Tesla Semi has deeply divided the heavy-duty transportation industry. When Elon Musk officially announced that the Tesla Semi would go into mass production by the end of 2025 and ramp up in 2026, only for Bill Gates to respond that it could never fully replace diesel trucks, voicing a slew of doubts about its feasibility, battery weight, driving range, and charging infrastructure. Indeed, while specs and charging times always matter, the real test for any new heavy-duty vehicle like the Tesla Semi is how it's received by professionals who spend countless hours behind the wheel, because they're the ones who truly understand the hardships and hidden challenges truck drivers face every single day. Recently, the verdict from a veteran driver at U.S. transportation giant Saia, after testing the Tesla Semi on complex urban routes, handling pickups and deliveries with dozens of stops each day, has shed light on all the doubts we've had about the Tesla Semi in recent times. So, how does the Tesla Semi actually perform? And can it truly meet the harsh demands of the job, or is it just an idea on paper? Welcome to Tesla Car World. Stay with me. In just 1 minute, you'll see never-before-seen footage of the Tesla Model Semi testing. And join over 258,386 Tesla fans who get updates here before the media does. Subscribe today. Right now, the Tesla Semi is facing major challenges in winning over customers. As to date, there are only just over 300 units in operation, some Gen 1 models used internally at Tesla's own factories, and a small number of Gen 2 units being tested in real-world conditions by heavyweights like PepsiCo and Walmart. That's right. According to our latest survey, as many as 42% of respondents believe the Tesla Semi is the most difficult vehicle Tesla has ever tried to produce, let alone mass produce and bring to market. Even so, alongside all the debates and skepticism, Tesla continues to push forward, actively testing the Semi in real-world conditions and preparing for mass production by the end of this year. The newly redesigned Gen 2 version features a more spacious cabin, larger windows, and an available sleeper option, promising improved performance and drivability. Most importantly, the FSD system is ready, positioning these trucks to become the first fully autonomous models capable of operating with 100% driverless mode. We know that implementing full FSD on heavy-duty trucks could spark major controversy over safety and real-world usability. But many customers may welcome it as an innovation that could make the truck driving profession significantly easier. With your real-world experience driving heavy-duty trucks, would you want a Tesla Semi running on 100% FSD? Let me know below. We're reading them all. Of course, we'll cover the detailed delivery schedule and Tesla Semi's latest plans in Part 2 of this episode. But first, let's see if it truly lives up to our expectations through the real-world testing done by a Saia driver. This latest test was far more challenging, not a quiet highway run, nor a downhill haul with empty containers like Pepsi or Walmart. The volunteer driver was Tom Sturba, who works for Saia, a nationwide less-than-truckload LTL carrier with a fleet of over 7,000 trucks. Tom tested the Tesla Semi on congested urban routes, making 10 to 15 stops per day, facing everything from gridlocked traffic to navigating tight loading docks. This was real, demanding work designed to push the truck's durability, maneuverability, and ease of use to the limit. After several days behind the wheel, Tom was completely convinced by the Tesla Semi's design and performance. One of the biggest highlights was the real-world power of its electric motors. Compared to internal combustion engines, the electric drivetrain runs more smoothly and delivers stronger pulling power for most tasks, especially hauling loads. Most impressive was its ability to accelerate quickly from a red light without any lag. It could ease forward at the green and keep accelerating without falling behind surrounding traffic, a huge advantage in the LTL environment, where tractor-trailers often struggle through city congestion to make deliveries on time. Powerful as it is, the Semi is also remarkably agile. Contrary to the image of massive machines that are hard to maneuver, the Tesla Semi offers surprising handling. Honestly, this was one of the biggest surprises. Its urban driving performance is outstanding. With maneuverability that's nothing short of impressive and a tighter turning radius than traditional two-axle trucks. Tractor-trailers are massive machines, measuring meters in length and width with turning radiuses often measured in yards rather than feet. But the Tesla Semi is different. Its turning radius is much tighter, and thanks to improved maneuverability, driving becomes far easier, whether you're making a turn at a busy city intersection or backing a trailer into a cramped loading dock. This makes navigating crowded intersections or reversing into tight loading bays far less stressful, a huge plus for drivers in day-to-day operations. At first, Tom said he was surprised and admitted it took him a little time to get used to having not just one, but two screens. However, he quickly became hooked, especially with the semi's integrated navigation system and the impressive clarity of its cameras. These experiences have changed the way Tom views electric trucks. He shared that he prefers driving the Tesla Semi over a gas-powered truck, and even hopes it will be the vehicle he finishes his career with. This positive assessment reflects not just his personal experience, but also the results of a comprehensive SIA test designed to run the Semi under the toughest conditions to fully understand its capabilities and limits. Recent real-world testing has shown that the Tesla Semi can achieve a range of over 800 kilometers and charge from 5% to 80% in just about 45 minutes. In LTL operations, drivers only need to charge once a week, and the electric motors require no routine maintenance, a significant advantage in the trucking industry, where LTL accounts for 5 to 15% of annual revenue. As Tesla moves from testing to mass production, support from real drivers like Tom stands the strongest proof of the Tesla Semi's real-world capability. It's not just a truck with impressive specs, it delivers an outstanding driving experience for those behind the wheel every day. As promised, let's move on to what is the production and release schedule of the Tesla Semi? Mass production is on the horizon, and based on recent images, the upcoming 2.0 version will feature a refreshed design. While the Tesla Semi has technically been in production for years, the current trucks are still prototype units. The new 2.0 model will be the true mass production version, incorporating changes drawn from everything Tesla has learned through real-world testing. One of the main reasons for the long wait has been Tesla's need to collect operational data from customers like PepsiCo before locking in the final design. This testing stage hasn't just helped Tesla refine the truck, it's also been vital for proving how it performs under real-world conditions. Only after gathering enough data will Tesla commit to full-scale manufacturing, because nobody wants to roll out a truck that isn't bulletproof, right? Now, with the Tesla Semi production facility at the Nevada Gigafactory nearly ready, and large-scale testing with major logistics companies wrapping up, Tesla has started sharing key updates that set the Semi apart from its original prototype. Recently spotted images reveal clear refinements to the Tesla Semi's front fascia, bumper, and overall body contours compared to the current version. Across the U.S., updated Semi prototypes have been photographed, and while the units seen in various states appear to be the same new generation, subtle design differences can be picked out on closer inspection. Alongside the addition of a Model Y-style LED light bar, the Gen 2 Semi now features a larger windshield and the long-anticipated sleeper cab option, both of which were missing from the original prototype but are now fully incorporated into the latest builds. While the original day cab served as the program's flagship, one recently cited shrink-wrap truck could be one of several upcoming configurations. This particular unit is believed to include a sleeper cab, purpose-built for long-haul transport. Extended windows and a sleeper compartment are among the most notable changes. Window glass now spans about 70% of the rear section behind the driver's seat. This strongly suggests that Tesla has reworked the space into a sleeper area, something the company had hinted at in the past. In the latest side view shots, you can clearly see a black module mounted above the secondary cabin, the sleeper area, a space that was once completely empty. For long-haul truckers, a proper sleeping setup is essential, and Tesla now appears ready to provide exactly that. Tesla also seems to be planning multiple Semi configurations, including both high-roof and low-roof models. The high-roof version is designed to allow air to flow smoothly over standard cargo containers, while the low-roof variant reduces frontal surface area for better aerodynamics when pulling lower-profile loads. Recent spy shots also suggest that the cabin roof length has been cut visually by about 50% compared to earlier builds. In Tesla's official photos, this roof section stretched the full length of the cabin, something that's clearly been shortened in the latest design. The cabin height has also been noticeably lowered, though this might have been part of Tesla's testing plan from the start. The tweak seems aimed at striking the ideal balance between interior practicality and reduced aerodynamic drag. Another fresh addition is an electrical junction box now integrated into the cabin's side panel, replacing an area that was previously empty. This change not only sharpens the truck's appearance but also makes better use of available space. That said, it might be premature to get too excited. With Tesla's current resource limitations, some of the biggest upgrades in this refreshed model may debut in small numbers at first. The most important enhancements in this release center on next-gen battery technology, streamlined manufacturing, and core systems to enable future full self-driving capability. Still, the long wait to see Tesla semis become a regular sight on southern U.S. highways may finally be over. Indications strongly suggest that mass production has already begun quietly behind the scenes. According to Dan Priestley, the Gen 2 model will introduce new drop-glass windows to make yard and port operations much easier, along with Tesla's new HP battery pack. A unit that's cheaper to produce, has a lower raw capacity, yet delivers over 7% greater efficiency than the pilot version. The Semi will now be offered in two range options, 500 miles and 300 miles. Both will feature redesigned side mirrors and drop-down windows to improve driver visibility and simplify interactions with external systems, such as terminal kiosks at shipping ports. In the past, transport companies had to pay a premium for the standard 500-mile version, even if their routes were short, like urban deliveries or regional runs. That extra cost was a heavy burden for many small and mid-sized operators, especially when they couldn't take full advantage of the truck's extended range. With Tesla's updated configurations, the Semi can now be matched to the specific needs of each operation. Entry models with 250 to 300 miles of range are now available, ideal for shorter hauls, allowing businesses to skip paying for unnecessary features while still enjoying the key benefits that make the Tesla Semi attractive: low running costs, strong performance, and an eco-friendly footprint. Even these base versions keep Tesla's trademark qualities: robust electric motors, quick acceleration, and an aerodynamic shape that boosts efficiency. By trimming high-cost extras like maximum range and advanced driver assistance, Tesla has lowered the entry price, making electric trucking more attainable and realistic for a broader range of fleets. How well does the Tesla Semi's performance justify the $170,000 price? The Semi has always made waves with its beast-like power, but Tesla clearly isn't stopping there. Out of all Tesla's electric models, if there's one that truly pushes the boundaries of physics, it's the Semi. Normally, a semi-truck with a gross vehicle weight of up to 80,000 pounds would be expected to perform sluggishly, which is exactly why electric trucks have long faced skepticism from industry experts. The Tesla Semi is engineered so radically that it has the potential to convince truck drivers to stay in the profession at a time when the U.S. is dealing with a worsening driver shortage. For the first time ever, an electric truck can travel up to 800 miles on a single run when unloaded, while saving as much as 1 million gallons of diesel, roughly $3.5 million in operating costs. That's why Elon Musk has often called the Semi a money-making machine. From what we know, the Tesla Semi has so far been delivered to at least 7 major transport companies, including PepsiCo, DHL, Martin Brower, Costco, Saia, Walmart, and Watt EV. Most recently, ABF Freight, a division of ArcBest, wrapped up its own Semi trial with impressive results. The findings showed that the Semi is fully capable of handling real-world trucking operations. According to reports, ABF Freight successfully completed a 3-week test program, putting the Semi through highway transport applications. They released the results after covering nearly 4,500 miles with the electric truck. Their report stated, over a 3-week period, ABF operated a Tesla Semi on standard scheduled lanes, including over-the-road routes between service centers in Reno, Nevada, and Sacramento, California. The trial also included regional trips in the Bay Area and rail shuttle operations. The electric Semi traveled 4,494 miles in total, averaging 321 miles per day with an overall energy efficiency of 1.55 kWh per mile. The results from this latest trial highlight some major advancements. First, with nearly 4,500 miles logged and an average of 321 miles per day, the Tesla Semi proves it's not only well-suited for regional routes, but also capable of performing efficiently on long-haul runs. This is especially significant because, among all electric trucks currently in operation worldwide, the Tesla Semi is virtually the only one that can handle true long-distance transport. Thanks to its ability to travel up to 500 miles on a single charge. At present, no other electric truck on the market can match that. That's why we can confidently say the Tesla Semi is the only electric truck currently viable for long-haul freight needs. At the 2023 Run on Less event, manufacturers like Tesla, Freightliner, and Volvo showcased their electric truck models side by side. Real-world testing has shown that a single Tesla Semi can cover up to 1,076 miles in a single day. By comparison, PepsiCo's fleet of semis has averaged 613 miles per day, while OK Produce's Freightliner e-Cascadia fleet managed just 204 miles per day. The performance gap is striking. PepsiCo's semis collectively logged over 27,000 miles, whereas the second-place fleet running Volvo VNR trucks covered only about 5,200 miles. This disparity clearly demonstrates that the Tesla Semi leads not just in range, but also in real-world operational efficiency. As noted earlier, the Semi can reach close to 800 miles when unloaded and 500 miles at a full gross vehicle weight of 80,000 pounds. This capability comes from its large 850 kilowatt-hour battery pack. With the 1.55 kilowatt-hour per mile efficiency recorded by ABF, the Semi can easily complete a 321-mile trip on a single charge, and still have enough battery left to travel at least another 220 miles. An efficiency of 1.55 kilowatt-hour per mile is an impressive figure, notably better than the 1.7 kilowatt-hour per mile average seen in previous trials from other companies. And it doesn't stop there. ABF Freight's report also stated, the truck performed well across a variety of RUIs, including a 7,200-meter climb over Donner Pass, and overall matched the performance of diesel-powered trucks. Driver feedback was overwhelmingly positive, with operators noting the vehicle's comfort, safety, and ease of use. Features like the center seating position, wide visibility, and intuitive controls all contributed to an excellent driving experience. Elon Musk has repeatedly highlighted the Semi's acceleration capabilities since its debut. Steep and sustained grades pose no problem for this Class 8 electric truck, even at full load. As Musk put it, the best diesel trucks can only manage about 45 miles per hour on a 5% grade. The Tesla Semi can do 65 miles per hour on that same incline. With global operational potential, the Tesla Semi is more than just a U.S. market solution. It's a platform that could scale into markets worldwide, including Europe. This is especially critical as freight demand continues to grow and cutting transport-related emissions becomes a top priority. Which feature of the Tesla Semi impresses you the most? Range, acceleration, or full self-driving technology? Drop your thoughts in the comments. We'll reply to the top ones. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.
We have a new mirror design. Better sight lines, better aerodynamics, better performance overall. On top of that, we added a drop glass. There's a lot of fixed infrastructure, whether it's gate operations or interacting with a port or telecom. These will make drivers' lives easier.
A few weeks ago, the semi-assembly team at Giga Nevada wrapped up production on the final 32 first-gen Tesla semis. They're now gradually making their way into the hands of priority customers of Tesla. While early adopters are giving positive feedback on the transition to using electric Class 8 trucks, many have pointed out that these Tesla semis still fear the cold and are only best suited for short-range urban routes. That's about to change. Recently, at the Tesla Semi factory, over 1,000 new engineers and workers were added to the production line, all fully prepared to assemble the second-generation Tesla Semi, featuring an all-new battery system, a redesigned headlight setup, and 18 other wild upgrades developed by the Semi team over years of beta testing. These new Semi units are expected to launch in October, with a planned production capacity of 50,000 vehicles per year during the ramp-up phase, starting in late 2025 and continuing through 2026. So, what does the Tesla Semi Gen 2 really look like? And is its new price justified by the design and features it offers? Welcome to Tesla Car World. So, how does the new Tesla Semi Gen 2 price break consumer expectations? Among all of Tesla's electric vehicles, if there's one that truly seems to defy the laws of physics, it has to be the Tesla Semi. Typically, a semi-truck weighing up to 80,000 pounds would be expected to perform poorly. That's why electric trucks have long been met with skepticism from industry experts. The main reason lies in the design. Electric trucks require massive, heavy batteries to meet the demands of long-haul freight transportation. Many have argued that batteries simply can't deliver energy efficiently enough for such durable, long-distance vehicles. However, Elon Musk didn't hold back in his rebuttal. He boldly claimed that heavy-duty engines can run on batteries. For the first time in history, an electric truck can travel up to 500 miles fully loaded and up to 800 miles when empty, while saving as much as 1 million gallons of diesel fuel, translating to roughly $3.5 million in operating costs. That's why Elon Musk has always called the Semi a money-making machine. Adoption of the Tesla Semi hasn't come without hesitation. The sky-high price tag may be a barrier for mid-sized carriers, yet major companies like PepsiCo, Walmart, and Cisco have already added the Semi to their pilot fleets, drawn in by its reliability and the promise of improved driver retention. Meanwhile, the race to build out charging infrastructure is heating up. Tesla's Megacharger network is leading the charge, with plans for 1.2 megawatts via 4 stations and 46 public sites expected by 2027. This far outpaces third-party competitors and helps ease charging concerns for fleet operators. While traditional diesel truck makers are also feeling the pressure. Legacy OEMs like Daimler and Volvo are accelerating their own electric truck programs, but none can currently match Tesla in terms of projected production scale or its vertical integration across batteries, power electronics, and charging systems. When Tesla first unveiled the Semi in November 2017, the company confidently quoted $150,000 for the 300-mile version and $180,000 for the 500-mile variant, while the exclusive Founder series carried a $200,000 price tag, figures that undercut typical Class 8 diesel rigs and sparked excitement about an electric haulage revolution. Those early manufacturers' suggested retail prices positioned the Semi as both an environmental leap and a smart financial choice, promising fleet operators fuel savings of 20 cents per mile and a clear lifetime cost advantage over diesel counterparts. Fast forward 8 years, and, while global inflation and battery innovation have shifted the sticker price, they've also enhanced performance, reliability, and long-term savings in ways few anticipated. Take the recent Rider pilot program. They initially planned to deploy 42 Semis but refined their order to 18 after seeing updated cost projections near $400,000 per truck. At first glance, that huge number feels daunting, but it reflects not only higher material costs, but also Tesla's cutting-edge battery chemistry, tri-motor efficiency, and an integrated charging ecosystem designed to minimize downtime and maintenance calls. Viewing that $415,000 figure purely as an upfront expense misses the bigger picture. These trucks are engineered to slash operational costs and unlock savings over their entire service life. Inside Tesla's own planning documents, now circulating online, we see a mass production BOM floor of $250,000 to $300,000. Again, it's tempting to compare that to the $150,000 and $180,000 promise of 2017. But remember, this new baseline buys fleets advanced aerodynamics, on-route Megacharger access, and features like electric power takeoff that eliminate auxiliary diesel generators. In real-world terms, You're investing in a vehicle that pays you back while on the road. Central to Tesla's pitch is total cost of ownership, TCO. A Tesla Semi that uses 1.6 kilowatt-hours of electricity per mile at an average electricity cost of 8.32 cents per kilowatt-hour results in a fuel cost of approximately 13.3 cents per mile. In comparison, a diesel truck currently costs around 44.7 cents per mile to operate. The difference between the two is about 31.4 cents per mile. Translates to roughly $314,000 in savings over 1 million miles. Layer in a conservative 15% maintenance reduction. For example, 15 cents per mile compared to 20 cents per mile on diesel, and you gain another $7,500 per year for a medium-duty route, speeding up payback. Imagine a mid-sized carrier running 400-500-mile routes daily. Annual energy costs drop from $67,000 on diesel to under $20,000 with a Semi, freeing up over $45,000 each year. Paired with streamlined servicing and Tesla's over-the-air updates, that investment begins to look like a strategic asset rather than a cost burden. Even a 5.5-year payback on a $300,000 premium sits comfortably against typical 7-year truck cycles, especially as electricity prices continue trending downward. And to fully realize the Tesla Semi's optimized investment thesis, Tesla is simultaneously building the charging backbone needed to unlock its long-term savings. On July 29, 2025, Tesla activated a dedicated Megacharger bay at PepsiCo's Denver facility, ensuring Frito-Lay's pilot fleet can recharge quickly between runs. In California, PepsiCo and Frito-Lay have secured permits to install 8 more semi-specific chargers at their Bakersfield plant, eliminating range anxiety on high-throughput routes. Beyond corporate sites, Tesla is completing its first public Megacharger station at 1930,000 South Hamilton Avenue in Carson, strategically positioned near the Port of Long Beach to support heavy haul corridors. These customer and community-facing deployments are just the beginning. At the ACT Expo in April, Tesla announced a network of 46 Megacharger locations across the U.S. by early 2027, creating a contiguous charging grid that parallels diesel refueling hubs. With ultra-fast 1.2 megawatt charging posts at both private depots and public stops, fleet operators can plan predictable routes and minimize idle time. Coupled with the Semi's lower energy cost per mile and reduced maintenance, this expanding infrastructure turns a higher upfront price into a seamless, cost-efficient operation, transforming sticker shock into strategic advantage. What are the 18 insane upgrades Tesla is developing for the Semi? The Tesla Semi has always made a bold impression with its beast-like performance, but Tesla clearly isn't stopping there. All current semi-trucks are prototype versions delivered to a select group of customers for testing and data collection before Tesla finalizes the design and begins mass production at its new factory. Recent leaks suggest that the Tesla Semi is about to undergo some major design changes, particularly in the headlights, hinting at the upcoming launch of Tesla Semi version 2. We understand that some of these changes may be controversial, but many customers are likely to welcome them. So far, only around 500 units have been produced. Half have been delivered to customers, while the remaining half are retained by Tesla for internal use. One of the main reasons behind the delay in full-scale production is the need to gather real-world data from customers. Tesla is requiring feedback from PepsiCo and other early pilot partners during a minimum 2-year trial period before locking in the final production design of the truck. The testing phase not only helps Tesla fine-tune the design, but also serves as a crucial opportunity to evaluate the Tesla Semi's performance under real-world operating conditions. The data collected from major customers like PepsiCo provides valuable insights into how the truck performs outside of controlled environments. So even though the Tesla Semi was unveiled a few years ago, mass production hasn't begun yet because Tesla is still waiting on customer feedback before making final adjustments. Naturally, no one would be reckless enough to mass-produce a vehicle that hasn't been fully developed. It would be riddled with issues. That's why, as the Semi's production facility nears completion and the trial phase with logistics companies comes to a close, Tesla has revealed several changes to the Semi compared to the original prototype. We believe the updated design looks modern and aligns well with Tesla's current design language. We're hopeful that the upgraded version will look like this, because in our view, the Semi looks significantly better with the LED light bar than it does with the current headlight setup. We're genuinely excited to learn more about Tesla Semi version 2. And it's not just about the headlights. Dan Priestley has confirmed that several other elements will be refreshed as well. We believe there are still many more changes Tesla is working on that have yet to be revealed. What we've seen so far is just the beginning, and it's clear that Tesla is keeping plenty of upgrades under wraps. One notable point, though not officially announced, is that there are growing signs Tesla Semi Generation 2 may be launching soon. Dan Priestley has shared that Tesla plans to introduce a new electric truck model with a sleeper cab, allowing drivers to handle long-haul deliveries with greater comfort. However, the release of this version still depends on the progress of Tesla's new factory and the rollout of its Megacharger stations. This more premium model is expected to be built at the new facility, since Giga Nevada currently only has the capacity to produce prototype versions of the Tesla Semi. At the moment, the Tesla Semi still uses 2170 battery cells with a total capacity of 900 kilowatt-hours, but a transition to a new battery type is on the horizon. The new 4680 battery cells are expected to replace the 2170 cells currently powering the heavy-duty trucks. You might not know that the factory expansion in Nevada has been fast-tracked. According to reports, 2 new production facilities will be built as part of the expansion. One dedicated to manufacturing 4,680 format battery cells with an annual capacity of 100 gigawatt-hours, and another for mass-producing the Tesla Semi-electric truck. It's hard to imagine that the Tesla Semi wouldn't eventually use battery cells produced at the same site, especially since doing so would offer Tesla significant cost advantages. Moreover, the Semi has already faced long delays while waiting for the 4680 cells to become available, which may explain why only around 100 trucks were produced between 2022 and 2023. According to Tesla, the availability of 4680 cells is now increasing, which could be great news for the electric truck program. Don't get us wrong, we fully expect the Tesla Semi to transition to 4680 batteries soon, but it likely won't happen overnight. The trucks currently being built at Giga Nevada are still using 2170 cells, and if our assumptions are correct, once the dedicated Semi factory is completed and Generation 2 goes into production, the trucks will be equipped with 4680 batteries. The 4680 battery is a much better fit for Class 8 trucks than the 2170 cell, not just due to its improved performance, but also because of the enhanced safety benefits. With an advanced design that allows for superior thermal management, it dissipates heat more effectively and reduces the risk of thermal runaway, a dangerous condition that can lead to fires or explosions when a battery overheats. The tabless design of the 4680 battery not only reduces internal resistance, but also enhances thermal control, making it safer when operating under high performance. Its larger size allows the 4680 cells to be integrated directly into the vehicle structure, improving both durability and crash resistance. This is especially critical for trucks like the Tesla Semi, where safety and performance are key priorities. With the 4680 battery, the Tesla Semi not only achieves greater range, but also provides greater peace of mind when it comes to safety, ready to meet the demanding needs of future freight transport. However, it's clear that battery safety alone doesn't determine the overall safety of an electric truck. Driver behavior also plays a major role. In reality, even the least safe lithium-ion batteries cannot cause fires or explosions without some form of collision. In a recent fire incident, although it's still unclear whether the driver fell asleep or lost control, it was evident that something was missing from the Tesla Semi. That's right, it was full self-driving capability. The good news is that Tesla is actively preparing to integrate full self-driving into the Semi, as recent footage has shown. Tesla's Semi doesn't just look futuristic, it's a masterclass in aerodynamic engineering. Early prototypes already boasted an impressive drag coefficient of 0.36, more than 30% lower than a typical Class 8 diesel truck, around 0.5 to 0.6. That alone translates to roughly 10% fuel savings on highways. For the production model, Tesla has refined every contour. Fully sealed wheel covers eliminate turbulent air pockets around the tires. A smoother undertray prevents airflow separation beneath the chassis. And retractable side skirts bridge the gap between tractor and trailer, cutting wake drag by up to 20% versus a rig with generic side panels. To put this in perspective, traditional trucks with flat underruns see seed spikes to 0.65 in crosswinds, meaning the Semi slices through air with nearly half the resistance, boosting range and reducing energy consumption in real-world conditions. Underneath that sleek shell lies a tri-motor powertrain married to Tesla's latest battery chemistry breakthroughs. Retaining its three-motor layout for robust torque delivery, the Semi's production version uses next-generation cells that enable a 7% efficiency gain over trial packs, thanks to higher energy density and lower internal resistance. In practice, the 300-mile and 500-mile variants now consume under 1.85 kilowatt-hours per mile, even when fully loaded, comparable to a light-duty EV, while diesel competitors burn through 50 to 60 liters of fuel per 100 kilometers, is approximately equal to 1.8 kilowatt-hours of energy consumption for every mile traveled at similar loads. Moreover, by reducing total battery mass, Tesla lightens the truck by several hundred kilograms, further improving payload capacity and handling. Inside the cab, Tesla flips conventional ergonomics on its head with a driver-centric cockpit. The seat is centered, offering equal visibility down both sides of the highway and eliminating the off-center perspective of traditional left-side driving. Dual 15-inch touchscreens flank the steering column, consolidating vehicle data, navigation, and telematics into intuitive, context-sensitive displays. No more toggling between gauges and infotainment menus. A panoramic drop glass door on the passenger side swings open for effortless cargo checks at stopovers, replacing the need to clamber down and around the cab. The optional heads-up display projects critical route guidance directly onto the windshield, slashing glance-away times and contributing to a projected 15% reduction in driver fatigue over long hauls. Will Tesla's planned network of 46 Megacharger stations by 2027 genuinely meet long-haul trucking needs? Or is the company painting a picture of perfect infrastructure that remains out of reach for most transport fleets? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to see Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye. Tesla Semi continues to capture widespread attention with its exceptional performance, standing out impressively even in its earliest runs against traditional diesel trucks. Yet, what we have witnessed so far is the initial testing phase. As of now, all operating Semi vehicles are prototype models, delivered to a select group of strategic customers for real-world testing and data collection. This critical phase is aimed at refining the final design before Tesla transitions to full-scale mass production at its new facility by the end of this year. A new Tesla Semi prototype has also been spotted, the second one this month after years without any fresh builds, revealing that Tesla Semi is undergoing major transformations in both design and operational cost efficiency. Beyond the redesigned headlights, the new version features a significantly wider cabin with expansive windows and the long-awaited sleeper cab option, now officially implemented in the mass-produced Tesla Semi Gen 2. So, what has changed in the Gen 2 design for full-scale production? And how much of a game-changer is its real price? Welcome to Tesla Car World. We're certain that some of the latest design changes on the Tesla Semi version 2 will spark debate within the user community. However, many customers and industry partners view these updates as essential improvements that better align with real-world needs. In today's episode, we'll dive into the newest updates on the second-generation Tesla Semi, Review recent test results under actual operating conditions, and take a close look at the current production progress at the Tesla Semi manufacturing facility. Elon mentioned he wants to do everything he can, and that it's time to bring the Tesla Semi to production. Yet his comments focused mainly on the battery and drivetrain systems at Gigafactory Nevada, something we already knew. As for the rest, he added that it would maybe happen in other states. Many investors argued that despite significant advances in battery technology, electric vehicles remained impractical for heavy freight transport, such as semi-trucks and cargo trains, due to the bulk and weight of the batteries required. But Elon Musk firmly pushed back. Tesla wasn't just building an electric truck. Musk was aiming to revolutionize the entire freight industry. The Tesla Semi was engineered to be so groundbreaking that it could actually help retain drivers, at a time when the U.S. is grappling with a severe shortage of transport labor. From the very beginning, the Tesla Semi was capable of traveling up to 500 miles unloaded and promised savings of up to 1 million gallons of diesel, translating to roughly $3.5 million in operating costs. Musk has consistently called the Semi a money-making machine. However, since its initial reveal back in 2017, the Tesla Semi has faced nearly 8 years of delays. To date, only about 200 to 300 units have been delivered to selected trial customers, while the rest remain within Tesla's internal fleet. The biggest reason for the delay lies in Tesla's need to gather real-world operational data from customers like PepsiCo in order to finalize the design before entering mass production. This testing phase hasn't just allowed Tesla to fine-tune the vehicle. It has also served as a critical opportunity to evaluate performance under real-world conditions. Only once enough data has been collected will Tesla lay the foundation for full-scale manufacturing. After all, no one wants to mass-produce a truck that isn't rock-solid, right? But now, with the Tesla Semi production facility at the Nevada Gigafactory nearing completion and the testing phase with major logistics companies coming to a close, Tesla has begun revealing several key updates to the Semi compared to its original prototype. Zanigler, a longtime Tesla watcher known for drone footage tracking factory progress, recently captured a new Tesla Semi wrapped in protective film, showing noticeable refinements to the front end, bumper, and overall body lines compared to the current model. Spy shots of updated Tesla Semi prototypes are now surfacing across the country. While the trucks spotted in different states appear to be of the same new variant, a closer look reveals subtle differences between them. In addition to the Cybertruck Cybercab Model Y-style LED light bar now featured on the Semi Gen 2, Tesla has also introduced an expanded windshield and the long-awaited sleeper cab option, features absent in the original prototype, but now fully integrated into the latest builds. While the original day cab served as the face of the program, the newly spotted shrink-wrapped truck may represent one of several additional variants. The latest unit observed likely includes a sleeper cab, fundamentally designed for long-haul routes. Extended windows, sleeper, compartment. One of the most significant changes I've noticed in this prototype is the expansion of the window area. It now stretches across roughly 70% of the rear compartment, the space located behind the driver's cabin. I believe this could indicate a conversion of that area into a sleeper cab, something Tesla has previously hinted at. Back in a 2018 article about the Tesla Semi, I speculated that this space would eventually be repurposed, and now it appears that prediction is coming true. You can spot a black module positioned above the secondary cabin, sleeping area, in the latest side photos. This space was previously empty. Truck drivers need a proper sleeping setup, and Tesla seems fully prepared to deliver exactly that. The rear panel now protrudes slightly more than before, and the lower body contour has been shortened and reshaped to accommodate the updated side profile. Tesla is also offering multiple configurations of the Semi, including both high roof and low roof variants. The high roof design allows smooth airflow over the top of standard cargo containers, while the low roof version improves aerodynamics when hauling lower profile freight by reducing the truck's frontal surface area. According to recent spy shots, the cabin roof length has been visually shortened by approximately 50% compared to earlier versions. Previously, this area extended the full length of the cabin, as seen in Tesla's official photos. The cabin height has also been noticeably reduced. However, this adjustment may have been part of Tesla's testing process from the beginning. The change appears aimed at finding the optimal balance between interior utility and aerodynamic drag reduction. Another new detail: an electrical junction box has now been integrated into the side of the cabin, replacing what was previously an empty space. This not only improves the vehicle's visual aesthetics, but also optimizes space utilization. However, it may be too soon to celebrate. Given Tesla's current resource constraints, some of the most significant upgrades in this revamped model may initially be released in limited quantities. The most impactful changes in this rollout focus on upgraded battery technology, improved manufacturing efficiency, and foundational support for future full self-driving integration. The long wait to see the Tesla Semi becoming a common sight on southern U.S. highways might finally be coming to an end. All signs now point to mass production having quietly begun. According to Dan Priestley, head of the Tesla Semi program, the Gen 2 Semi will feature new drop glass windows designed to make yard and port interactions significantly easier, along with Tesla's new HP battery pack, cheaper to manufacture, lower in raw capacity, yet delivering over 7% better efficiency compared to the Pilot version. The Semi will be available in two range configurations, 500 miles and 300 miles. Both variants will now come equipped with redesigned side mirrors and drop-down windows to enhance driver visibility and streamline interactions with external systems, such as terminal control panels at shipping ports. Previously, transport companies looking to own a Tesla Semi had no choice but to pay a premium for the standard 500-mile range version, even if their daily routes were limited to short hauls, such as urban deliveries or regional logistics. This created a financial burden for many small and medium-sized businesses, especially when they couldn't fully utilize the truck's high-end features. However, with Tesla's new configuration options, the Semi can now be tailored to meet the specific operational needs of each business. For example, base versions with ranges between 250 and 300 miles are now available, ideal for short-distance transportation. This added flexibility allows customers to avoid paying for unnecessary capabilities while still benefiting from the core advantages that make the Tesla Semi so appealing: low operating costs, powerful performance, and an environmentally friendly design. Even the base models retain Tesla's signature qualities: durable electric motors, impressive acceleration, and an aerodynamic profile that boosts energy efficiency. By scaling back premium features such as extended range and advanced driver assistance systems, Tesla has significantly lowered the entry cost, making electric trucking more accessible and practical for a wider range of businesses. Even as a prototype, the Tesla Semi has proven its exceptional capabilities, not only during testing but also under real-world conditions. One of the key factors propelling the Tesla Semi to the top of the electric truck segment is its remarkable efficiency, outperforming every other competitor in its class. But what truly sets the Tesla Semi apart is its real-world range, a figure that no other electric truck has been able to match. From going farther on a single charge to maintaining consistent performance even under the harshest conditions, the Tesla Semi continues to raise the bar. And this isn't just an upgrade. Starting next year, customers will have the opportunity to own the Tesla Semi at a lower price point. Elon Musk has announced a breakthrough plan for this heavy-duty truck, offering customers an unprecedented level of flexibility. Instead of offering only a single 500-mile configuration priced at $250,000, Tesla will now allow buyers to customize their Semi based on actual operational needs. This means that if your daily driving range is only around 250 miles, you'll be able to pre-order a Tesla Semi specifically tailored for that use case. From our perspective, this program offers significant advantages for transport businesses, especially those that don't require long-haul capabilities. These operators will be able to substantially lower their costs by choosing the base variant, expected to start around $170,000. These upcoming models will also feature a new addition. The Electric Power Takeoff System, or EPTO, allows the Semi's high-voltage battery pack to power auxiliary equipment across a range of voltage levels. This includes devices such as refrigerated trailers with climate control. effectively replacing noisy, polluting diesel generators traditionally used for such tasks. Tesla is also actively developing an upgraded battery pack design for the final production version of the Semi. This new battery pack is engineered to be more cost-effective to manufacture. Although slightly smaller in physical size compared to previous versions, the truck still maintains a similar driving range thanks to improved energy efficiency. In a keynote address, Dan Priestley also confirmed that the battery cells for the Semi will be produced domestically in the United States, a move that helps mitigate potential tariff-related risks and strengthens supply chain resilience. On the charging front, Tesla is deploying the Megawatt charging system, with a capacity of up to 1.2 megawatts, purpose-built specifically for the Semi. This system utilizes the same V4 charging hardware found at supercharger stations, but is optimized for significantly higher power output. In addition to its more compact footprint, Tesla will be able to configure these V4 cabinets either for dedicated semi-charging or to share power with standard supercharger stations, depending on location needs. Tesla is also developing an integrated overnight charging solution, although it is yet to officially unveil this product. How is Tesla's Semi-factory ramping up for 50,000 trucks a year? In a major development, Tesla has recently hired over 1,000 new employees at Giga, Nevada, to ramp up the Semi-production line. A dramatic increase compared to the fewer than 100 workers previously involved in Semi-development across California and Nevada. The Semi-factory in Nevada is designed with a full-scale production capacity of up to 50,000 units annually. The first production intent builds are expected to roll off the line by the end of 2025, with mass production accelerating throughout 2026. At one point, Tesla had to halt the import of critical components from China for both the Cybercab and Semi due to former President Trump's tariff policy, with duties reaching up to 145%, making production economically unfeasible. However, following a de-escalation in trade tensions in late May 2025, Tesla has confirmed it will resume importing key components from China, enabling limited trial production to begin in October this year. Even as a prototype, the Tesla Semi has already demonstrated outstanding real-world performance, not just in controlled testing environments, but in actual fleet operations. During a 4,500-mile, 7,200-kilometer trial program with ABF Freight, the truck achieved an average energy efficiency of 1.55 kilowatt-hours per mile, approximately 0.97 kilowatt-hours per kilometer, covering an average of 321 miles per day across challenging routes that included steep climbs like Donner Pass. These results rival the performance of traditional diesel trucks and are particularly impressive for a long-range electric vehicle. Driver feedback has also been overwhelmingly positive, highlighting comfort, visibility, and the unique center seat cabin design as major strengths. Tesla has also committed to integrating supervised full self-driving capabilities into the version 2 Semi, a key feature that promises to help alleviate the growing driver shortage while improving overall operational safety. The ability to standardize FSD across heavy-duty trucks could mark a pivotal turning point in the emergence of autonomous freight transportation. To our knowledge, the Tesla Semi has so far been delivered to at least 7 major freight and logistics companies, including PepsiCo, DHL, Martin Brower, Costco, Saia, Walmart, and Watt EV. Most recently, ABF Freight, a division of ArcBest, completed its trial of the Tesla Semi with highly impressive results, demonstrating that the Semi is a fully capable and operational electric truck. In a defining moment for the Tesla Semi program, 2 major logistics companies, ArcBest and ThyssenKrupp Supply Chain Services, have completed extensive multi-week pilot programs with Tesla's all-electric Class 8 truck. These trials, conducted in real-world operational settings, delivered overwhelmingly positive results and confirmed the Semi's readiness for mainstream adoption. ArcBest, a leading freight and logistics company, announced the successful completion of a 3-week test program with the Tesla Semi. Over the course of the trial, the truck logged an impressive 4,494 miles, averaging 321 miles per day, on routes that included some of the most demanding terrain in North America, including the legendary Donner Pass, with elevation climbs reaching 7,200 feet, 2,100 meters. Even more impressive was the Semi's energy efficiency during the test. According to Tesla Semi Program Director Dan W. Priestley, the truck achieved a remarkable 1.55 kilowatt-hour per mile, a benchmark that, when compared to Tesla's own Model 3, around 0.25 kilowatt-hour per mile, showcases the Semi's efficiency despite its much larger size and payload capacity. In other words, the Semi consumes about 6 times the energy per mile of a Model 3, while hauling exponentially more weight. ArcBest reported that the Semi's performance was on par with conventional diesel trucks, a powerful endorsement given the long-standing dominance of diesel in heavy-duty freight. Most importantly, the trial was conducted under genuine transport conditions, further validating the Semi's durability and readiness for daily logistics. Operators praised the truck's comfort, safety, and intuitive controls, noting that the center seat driving position, expansive visibility, and aerodynamic cabin design contributed to an enjoyable and stress-free experience behind the wheel. From design to real-world use, the Semi appears purpose-built not only for sustainability and cost reduction, but also for driver satisfaction. In a separate but equally notable announcement, ThyssenKrupp Supply Chain Services revealed that it had also completed a successful 3-week trial of the Tesla Semi at one of its logistics hubs in California. During this winter test, the vehicle covered nearly 5,000 miles in a variety of operational environments, including regular climbs over the steep Altamont Pass. So, what do you think about Semi Refresh? Is the $170,000 starting price for the base model genuinely affordable for small and mid-sized businesses, or is it just clever marketing to mask the truck's still high real cost? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.